You are welcome to the Untitled Academy, where we are devoted to building excellence in students, especially when it comes to the STEM subject. This video today is going to be a walkthrough of the 13 questions from the WAEC 2021 Mathematics Exam Theory paper. We are going to be looking at all of the questions, give you tips, hints, tricks that can help you to solve these questions if you come across them. And we are going to be covering a whole lot of sections in mathematics, talk about commercial mathematics, word problem, bearing and distances, circle theorem, statistics and probability, set theory with Venn diagrams, graphing functions, triangles, quadratic equations, linear equation, measuration, standard deviation, and so much more. So we just want you to get set, get ready, and if you're preparing for any O-level exam at all, talk about your WAEC, GCSE, NECO, GED, GCSE, IGCSE, you are going to find this video very, very useful. And you can even check our playlist for a whole lot of other questions that were also solved on various exams, even including JAMB. And this you'll find quite useful as you prepare for excellence on your journey. Our work is so much set before us, so we want you to just get your pen, get your biro, get your calculator, walk along. You don't get to master all these principles just by watching the video. It's as you put your hands to paper, as you get your hands dirty, that you get to be proficient in all of this. And if you are here to subscribe to the channel, just it's a click away and it's free of charge. Click on the notification bell also, so that you have access to all of our video resources as we upload them. And then let's go ahead and do our video for today. In this question on simple interest, we are told that Mr. Safo borrowed $25,000 from FIAC Financial Services at 21% simple interest per annum, and he did that for 3 years. Now, he was able to pay back the loan in 2 years at equal yearly installments. So that means that he paid the same amount of money each year, and he paid that for 2 years. So how much did he pay each year? Let's look at the question on simple interest. We already know that normally simple interest is principal times rate times time over 100. And if we identify all of this from the question, we can see that the simple interest to pay additionally on the amount is borrowing will be the principal, which is the amount that is actually borrowed, multiplied by the rate. We are giving that as 21%, okay, multiplied by the time. The time was originally for 3 years, and we can divide this by 100. So these zeros can cut out. So what we have here, we can use our calculator to say 25, okay, 250 times 21 times 3. So that simple interest is $15,750. Okay, so that is the amount that is going to be the interest capitalized on what he already borrowed. So the total amount he needs to repay, total amount to pay back, will be the addition of that capital originally, which is $25,000, plus this simple interest, which is $15,750. And if you are to evaluate that, so we add this plus 25,000, that is $40,750. Now, this is the amount that he needs to pay back. However, we are told that he paid back the full loan in 2 years at equal yearly installments. So for us to get how much he paid each year, we just need to divide the total amount that he needs to pay divided by 2. So amount he paid per year will just be half of this total amount that he needs to pay that we just got. So we can divide that and say that with this it will be 27 divided by 2, that will be 3. 15 divided by 2, that will be 7 and 5. Okay, so that's the division, that the amount is paying per year will now be $20,375. All right. Here in this word problem, we're told that two consecutive numbers are such that the sum of thrice the smaller and twice the larger is 17. We are to find correct to 3 significant figures, the smaller number as a percentage of the sum of the two numbers. So don't let's be intimidated. Let's just take this piece by piece. If you take those two numbers to be x as the first one, we are told that there are two consecutive numbers. So the next one will be x plus 1. So x can be anything. If x is 1, the next one will be 2. So we have 1, 2. And you can see they are consecutive. If x is 13, The next one will be 13 plus 1, that will be 14. That's why we have x and x plus 1, okay? So once we have that as what we're given, we're not being told that the sum of thrice the smaller one. Now here, the smaller one is x, and they're talking about thrice, so 3 times x, then we're talking about the sum plus twice the larger. Twice the larger will be 2 multiplied by x plus 1, okay? So that sum is equal to 17, okay? I think we have this and we should be able to solve this and get at least we can get the smaller number, okay? So if you open up this bracket, we have 3x plus 2 times x is 2x and 2 times 1 is 2 is equal to 17, such that 3x plus 2x is 5x. When we subtract 2 from both sides, here it will be 17 minus 2, which is 15. So 5x we can say is equal to 15, and divided both sides by 5, we can have x to be 15 over 5, which is 3. Now that means the numbers that we have are x is 3, and then the next number consecutively will be 4. So these are the two numbers, but this is not where we're supposed to stop. What we have to find is correct to 3 significant figures. We have to find the smaller number as a percentage of the sum of the two numbers. So that means what we are looking for is the smaller number, which is 3, as a percentage of the sum. The sum will be 3 plus 4, then as a percentage will be times 100%. Okay, so this is what we are inherently going to look for, and this will give us 3 over 7 multiplied by 100%. Okay, so we can bring in our calculator to evaluate this. So we have 3 multiplied by 100 divided by 7. Okay, so in decimal this is 42.857. So this is 42.857%. But look at what we have. So we are told to get that correct to 3 significant figures. And if we want to do that, we can just say this is approximately 3 significant figures, means that 3 digits is what we are going to write. So we can write the first two, 42 points. Now, to write the third one, we need to consider the number after it. 5, we round it up to 1 and add to this, so it will be 42.9%. That is going to be our answer for this question. All right. And pay serious attention to if you really want to get it. We are being told that a man left town M at 10 a.m. and traveled by car to town N at an average speed of 72 kilometers per hour. He spent 2 hours for a meeting there and returned to town M by bus at an average speed of 40 kilometers per hour. If the distance covered by the bus was 2 kilometers longer than that of the car, and he arrived at town M at 1:55 p.m. Our mandate is to calculate the distance from M to N. Wow. Okay. Student, you don't need to be frightened. Just interpreting this correctly will give you the solution to this on the fly. Okay. First and foremost, I'd like to define that we know speed to be distance over time. Okay. And in this particular case, because we have been given the speed, okay, we are looking for the distance. But from the information that we have, we can deduce the time for this particular journey. So I want to make T the sort of the formula here to say the time will not be the distance divided by the speed. Okay, so this will be a very good guide for us to try and solve this. And looking at the information that we are given, originally we are told that this man, he left at 10 a.m. and then he spent 2 hours at town N before he now returned back to town M, and obviously the route he took was different from the one he took originally, because we're being told that when he took the bus, the distance was 2 kilometers more than when he took the car. Okay, so that inherently means that he took another distance, but the distance we are being asked here is actually the distance that he took by car. Okay, so we can deduce the time that this man used here by saying that that time will be the time he arrived back at town M, 1:55 p.m. minus the time that he left the town M already, minus 10 a.m. Okay, let me just specify that as p.m. so that we will not mistake that. Minus 10 a.m. minus the 2 hours that he spent at town N. So I will say minus 2 hours. Now, 1:55 p.m. is the same as if we are having 13 55, okay, minus 10, okay, that is just 10, then minus 2 hours. So this will be nothing but 10 and 2 will be 12. So it's as if we have 1355 minus 12. That is 155. Okay. Now we're going to be working in fraction, and 155 is not ideal for our fraction. So we need to express it as a fraction. That will be 1 hour 55 over 60, because 60 minutes make 1 hour. This is like 1 hour 55 minutes, but we need to convert it totally to hour because our speed was even given in per hour. You can say 73 kilometers per hour, 40 kilometers per hour. So we just do what to append it like this. And if we want to do this, this will be 5 can go in 55, that will be 11. 5 can go in 60, that will be 12. So it is one whole number, 11 over 12 hours. Okay, that is the timing that this man took for the journey, both from town M to N and from town N back to M. We have considered the 2 hours that is spent for the meeting, and we have taken that out. So this is what we have holistically. So that is a very good starting point for us. But we also need to note that this particular time included his to journey and his fro journey. That means we can say that this total time that we are looking at is equal to the time from M to N plus the time from N back to M. So this is where it gets interesting now. So that time, okay, I can even say this is 12 times 1 is 12. 12 plus 11 will be 23. So I can say what we are having here is 23 over 12 hours at the total time is equal to what is the time taken from M to N. Here we define it as distance over speed, okay? What is that distance? It is x that we are looking for in kilometers over what is the speed? It is 72 kilometers per hour, okay? Plus the time the man spent from town N back to M. I hope this will be clear for you students. It's just these little breakdowns that will help us to solve this holistically, okay? So that will be, what's the distance from N back to M? We are being told that now it is x plus 2, and we are dividing it by the speed that is using from N to M, and that will be 40 kilometers per hour. So 40 kilometers per hour. This is the equation that we need to solve for us to get the distance from M to N, which is actually x, okay? So once we are able to get that, we should be good to go, and everything will be fine for us, all right? So this is what we have as our equation coming from our solution so far, and we can just find the LCM and try and see what we are going to have. This is going to be here on the right hand side. The LCM, I just want to walk straight and not try to be factoring out. I just want to say 72 and 40, that will be my LCM. Here, 72 times 40 divided by 72 is 40, so I have 40x plus here. Now 72 will be multiplying the two terms that we have as the numerator here. So I have 72 multiplied by x plus 2. So students, I hope that will be clear enough for you, such that with this, if I cross multiply, this is what I'm going to have, that 23 times 72 times 40 is equal to 12 multiplying the whole of 40x plus 72x plus 72 times 2 will be 144, okay, and I can now bring in my calculator to just punch in this number. Okay, I can still simplify this, but let me just take it piecewise. 23 times 72 times 40, 66240 is equal to 12 multiplied by 40x plus 72x will be 40 and 72, that will be 112x plus 144. Okay, so 12 I can actually use to divide both sides to say 112x plus 144 is equal to 66240 divided by 12, and that will give us what? So that answer divided by 12, this is 5520, 5520, such that 112x will be 5520 520 minus 144. So that will give us 520 minus 144, 5376, 5376. And with all of this now, I think I can just move my work a bit up. So having known that, what we are left with is that 112x is equal to 5376, and we divide both sides by 112. That means that x will be, this will cut. So we have what we are having initially, 5376 divided by 112 as our answer. Wow, okay. So x will be 48, and what is the unit? It is kilometer, because it is distance. So it's just as we took our information piecewise and just stick with the consistency that we know will eventually land us on the answer, that we're able to arrive at our final answer as x to be 48 kilometers. So that is a very good approach for us to take. If you have word problem like this, we don't need to fret. We just need to be consistent with what we are doing. And yeah, I ensure that if I'm opening up the bracket, it may give me some headache. So I stuck with the base means of solving this. Open up the bracket by multiplying the whole numbers together and eventually working out the algebra and finding the final answer as the distance from town M to N to be nothing but 48 kilometers. All right. In this question on bearing and distances, we are told that the point X, Y, and Z are located such that Y is 15 kilometers south of Z and Z is 20 kilometers from X on a bearing of 270 degrees. We are to calculate the distance YZ to two significant figures and the bearing of Y from Z to the nearest degree. Okay, to look at this question, we can see that in the first case, Y is going to be south of X, and then Z is also from X on a bearing of 270 degrees. So our point of interest where we need to start from is point X. And for us to just pick that, if we just say south of X will be down, and then 270 degrees of X will be just to the left of X. So we can just look at a convenient point and say if you want to call this X, and we are taking this as north, south, east, and west of the point X. So here we have our X here. First, we want to look at a scenario in which we are drawing south of X, which will be 15 kilometers, and that will take us to Y. So we can say here, at this point, we are having Y, and this distance is 15 kilometers, okay? And then we're also told that Z is 20 kilometers from X on a bearing of 270 degrees. And now, for us to take 270 degrees, we know north to east, that is a right angle, that is 90. East to south is another 90, making 180. South to west is another 90, making 90 plus 180, and that is 270. So, inherently, we are saying that 270 is actually to the west of point X, and that is 20 kilometers. So, just a bit longer than 15, and I think this will be good. Maybe I just need to move this a bit. And then this will take us to point Z, and Z is 20 kilometers from X. Then we can just finish up our diagram to say here we are having Z and Y, they can be linked like this. So in the first case, what are we have to find? The distance YZ. So this is YZ, and since it is opposite X, we can just call that small x. So this is small x. By looking at our diagram, we can see that what we're having here is nothing but a right angle triangle, because this here between the south and the west is 90 degrees. And for us to find x, we can make use of the Pythagoras Theorem. So we want to say in the first case, the first question, by the Pythagoras Theorem, we can just evaluate this and we'll be good to go. So in this particular case, we can just say that means that s squared is nothing but 20 squared plus 15 squared. Okay, so s squared itself will be 20 squared will be 400 plus 15 squared will be 225, so that the addition of both will be 625, and x, which is actually the line yz that we are looking for, will be the square root of 625. So we have square root of 625, that's 25. So this is even a perfect square. We're asked to find the correct of two significant figures, and we can see this is already in two significant figures, and then the first solution is out and we are good and fine. In the second case, we're asked to find the bearing of y from z. That means that we need to go to z, and at z we need to compute the bearing that we can get to locate the point y. So on z, if we draw our cardinal point just like here, we need to start from the north, we have the south, we have the east, and we have the west. Okay, no problem. So now we want to get the bearing of y from z, so we are taking it from z. Here we can see that first this is 90 degrees, okay, and if we can get this angle here, if I call that angle theta, so the bearing of y from z will be coming from the north and computing to the inclination of y from z, and that will be 90 plus this theta. So our mandate is to find this particular theta, and looking at the theta, we can use whatever we want to use by SOHCAHTOA. I think SOHCAHTOA will be very good for us. If we want to use SOHCAHTOA, we can say for this particular one, the opposite is 15, the hypotenuse is x, which just got to be 25. So we can say from here, sine theta, since we have the value of all the sides, we can even use anyone we like, maybe cosine or tangent, but I think I just want to use sine. Sine theta from this particular diagram will be the opposite, which is 15, over the hypotenuse, which is x, and that is 25. So theta will be arc sine 15 over 25, 5 can go, that will be arc sine 3 over 5. And if I want to compute that, 3 over 5 is actually 0.6, but I can just say I want to impute it directly. Arc sine, here I have 3, and then at the base I have 5. So I can go out, close the bracket, and solve for this. So this is 36.86989. Let me just take it as 36.87. Okay, so this is 36.87. But the bearing that we are looking for, that bearing, we have already identified it as 90 plus theta. So that will be 90 plus 36.87, and this will give us nothing but, we want to solve this, 90 plus 36.87 will be 126.87. But look at what we are given. We are asked to find it to the nearest degree. Even if you are not asked to find it to the nearest degree, bearings are only written in 3 digits. You don't put decimals in bearings. So this will be approximately, here 3 digits will be 1, 2, 3. But we need to consider the other numbers and round them up or down as appropriate. 8 will have to be rounded up to 1 and added to the initial numbers. So this will be 127 degrees. And with that, we've been able to solve this question on bearing and distance as requested. All right. In this question on circle theorems, we are going to use our understanding of the circle theorems and triangles to solve this question, and we'll be fine and dust it easily without any problem. So we are told that in the diagram, the line AD is the diameter of a circle with center O. So this is the center. Then if ABD is a triangle, ABD is a triangle in a semicircle. Okay, that's interesting. An angle OAB as given here is 34 degrees. We have to find angle OBD. So let's find that OBD. So this here, that's the angle we are first to find. If I call that X, and then angle OCB, OCB. So here, that's how you actually get the angle. I will call that Y. And these are the highlights of what we are expected to solve for in this question. So let's look at this diagram holistically and try and postulate what we can get from this. In the first case, I want to notice that the line from the circumference of the circle to the center is always the radius. So AO, here, this is the radius, and OB, this is also the radius. Interestingly, this here is also the radius, but I don't think we need that. But looking at this, meaning that triangle AOB is an isosceles triangle, and if it is an isosceles triangle, we know that the base angles of isosceles triangles, they are equal. So this angle here, that's going to also be 34 degrees. So I'm going to say that angle OAB that we are given is also equal to angle OBA, and the value is nothing but 34 degrees. Why am I saying this? Because they are base angles of isosceles triangle. So normally, if you are solving your questions, make sure you write the reason why you are postulating those theories. Okay, so with that, we have taken a very huge step that can help us to solve this holistically. In the second case, I can look at this particular triangle and say that since we are given AD to be the diameter of the circle and we have ABD at the circumference, then there's another theorem that tells us that the angle that is subtended by the diameter of a circle at the circumference is 90. So this inherently is nothing but 90. So I have it that the angle ABD, that is nothing but 90 degrees. And why am I saying that? It is angle subtended by diameter at the circumference. So I hope students you get this. Angle subtended by the diameter at the circumference. That is why ABD, that is why it is given as 90 degrees. And if we look at this, you can see that at point B, we are saying that angle OBA and angle OBD, which we are looking for, OBD, the two of them, they sum up to be the right angle 90 degrees, which is ABD. So let me just write that appropriately. They sum up to be angle ABD. That means inherently what we have is that, what is OBA? OBA is 34. So we have 34 plus OBD, which we are looking for, that is X, is equal to ABD, that is 90 degrees. So students, I hope you can get this on the fly such that X can be 90 degrees minus 34 degrees, and this is nothing but 56 degrees. And with that, we've been able to solve this question that angle OBD is 56 degrees. That is fine, good, and dusted. In the second case, for us to get this angle OCB, we'll notice that this line BC just touches the circumference only at a single point. So that is rendering it as a tangent. This is a tangent to this particular circle. Okay, so if we get that to be a tangent, then we also know that the angle between the tangent of a circle and the radius, and you can see BO is actually the radius of this particular semicircle. The angle between them is also 90. So I can also say angle OBC is nothing but 90 degrees. And why? It is angle between tangent and the radius of a circle. So if I put that, that is going to help me to solve this question holistically, because having gotten that, if I can find this angle here, I'll be able to sum this angle in blue, let me call that A, plus the 90 that is OBD plus Y, and equate them to 180 degrees because they are the sum of angles of a triangle. Since I know that, I can now look at this. How do I find A? There are two methods you can use, whichever is suitable. You can see that A is the exterior angle of the triangle AOB, in which the interior opposite angles are 34 and 34, so that A will be 34 plus 34. Or you can say that A is actually the angle subtended at the center of the circle, whereas BAD is angle 34. And by reason of the postulate of the circle theorem, we can say that the angle subtended at the center of a circle by a chord, so the chord is BD now, this angle subtended at the center is twice the angle subtended at the circumference. So whichever one you want to postulate, just say it, and you'll be good to say. Here, I will just say angle A, which I got to be angle OBD, is equal to 2 times angle OAB, and that means it is 2 times 34, which is equal to 68. And why am I saying that it is angle subtended at center O is twice angle at circumference? So again, I'm just using shorthand here, students, just for you to understand, so that you know how to write it in your exam, and that is getting us the value of angle A. Then from the triangle OBC now, triangle OBC, we can now see that A, which we just got, plus, okay, let me just even use the notation. A, we have it as OBD, angle OBD, plus angle OBC, plus the angle we have to find, OCB. The three of them is going to be 180 degrees. Why? They are the sum of angles of a triangle. Okay, so don't let me just I have very little space left. Don't let me write that. I'm stating this because they are the sum of angles of a triangle. And since I have that, I can now say, what is OBD? OBD we just got to be 68. So I can say 68 plus OBC. We have gotten that to be 90. Okay. Plus the angle we are looking for, OCB, plus Y. That is 180 degrees. Such that the Y that we are looking for is 180 minus the sum of 68 and 90 is 158. And if I subtract that, this will be 22 degrees. So 22 degrees, which is OCB, is Y, and X, which is 56 degrees, is angle OBD. And with that, we've been able to solve this question by making use of our understanding of triangles and the circle theorem, and we are good and fine. Here we have a question on statistics in which we are asked to represent the information here on a pie chart, which is showing the way a man shared his property among his children. And now if we want to do that, we can have this particular table that is going to help us put this information on a pie chart. This information was given in percentages. So you can see this was percentage share. So for the percentage share that we're given, that means that we need to look at all of these percentage share and ensure that they need to add up to 100. Like we say, 5 plus 15 is 20, plus 10, 30, plus 45, that's 75, plus 25, so this is 100%. And for us to get the corresponding angle that will be aligning with each of these percentage share, we need to calculate that angle. And in the first case, what we just need to say, the particular share of each child over the total, which is 100, multiplied by 360. And that 360 is going to be reflective of the angle that the share will represent on the pie chart. You can see this is a fraction of the percentage multiplied by the total number of degrees that we can have on a pie chart. So this is what we are going to do, and for each one we are going to have just the same thing. I just want to use the calculator to show students how you can do this on the fly, okay? Particularly if you have access to a calculator that can be intuitive, this can just be on the go. You can get this straight and fine, okay? So here is the calculator. I just want to put in this over 100, then I want to multiply by 360. So I'll just calculate what's the value of x in the first case, 5. So that is 18. I want to calculate again the value of x, 15, that's 54. The value of x again, when x is 10, that is 36. The value of x when x is 45, that is 162. And the value of x again when x is 25, that is 90. So we can have all those, and we just need to pull them and put them in this particular place. I think initially we got 18, and then if you're observant, 5 and 15, actually 15 is 3 times 5. So the next value here also, if you can get that first one, you can say this is 3 times 18, and that will be 54. Okay, for 10, that will be 18 times 2, this will be 36. Then for 45, that 45 will be the value of 15 times 3, because 45 is 15 times 3, so it is this 54 multiplied by 3, and that is 162. And then this is 25, is like 5 multiplied by 5, so 18 multiplied by 5, this is 90. So that's another way you can just go ahead to try and solve that. Just be intuitive to know that you don't need to be stereotyped to use any method. Just use what can be convenient, and these are tips that can help you be very fast when you are calculating. We also need to sum all of this to ensure that they add up to 360 so that we can represent them appropriately on the pie chart. So if you want to check that, you can say 18 plus 54 plus 36 plus 162 plus 90. What's that going to give us? So we're on track. This is 360, so we can say that this sum is 360. And then the onus is lying on us to now put all of this information on the pie chart, okay? And for us to put it on the pie chart, I just want to start with 90 because I know that 90 is a right angle. So this is looking like the center of the circle. So 90 can just go straight like this. So that will be Akosua. I will still label. Then which one am I seeing again that I can put very representative was 162 is going to be almost 180. 180 is going to be a straight line coming from down to up. So 162 should not be up to 180 like this. So it should be maybe something like this. 162. I think it should be fine. All right. Then we have 18, 54, and 36. And we are looking like we are saying that these are in ratios 5, 15, 10. So this is like ratio 1, 2, 3. Okay. 1, 2, 3 means that maybe you are dividing it into 6. 1 plus 2 plus 3, that is 6. So one is going to take like half. The other is going to take like 2. So half of this, let's say this is half of it. All right. This is half. So this is taking 3. So this is another 3. Then one should take 2 and the other should take 1. So I think this should be a very good representative of what we have. Just pictorial like that. And then don't forget to label. After doing all of this, you can now say you want to label who is having 90 degrees. So let's say we have this as 90. That is Akosua. And that is a right angle. And then who is having 162? That is Nuno. So here we have this is 162. And what is 162? That is for Akosua. Okay. And then the one having the larger out of the 3 is Afia. That is 54 degrees. So we have 54 degrees. And that is for Afia. Okay. And then we have 36. 36 will be for Kiji. So here, this is 36. And that is for Kiji. And then 18 will be for Ann. So here, this is 18 degrees. And it is for Ann. And with that, we've been able to just look at this and put in the information as we are requested. This is 90 degrees. And we have answered this question holistically as expected of us. All right. Here in this question on probability, we are told that a box contains 5 red, 3 green, and 4 blue identical bits. Our mandate is to calculate the probability that a girl takes away 2 red bits, one after the other, from the box. So what we need to know is that we are looking at probability in this case, and probability as has been defined is actually the ratio of your desired outcome over the total possible outcome that you can get out of a case scenario. Okay, desired outcome will be what we are looking for. Possible outcome will be the total number of instances that we can actually have to be occurring. Okay, now for this particular case, we are saying that a girl is taking out first and foremost 1 red ball, and to take that 1 red ball, we can actually see that from here the total balls that we have will be 5 plus 3 plus blue. So now the possible outcomes that we have in this case, since we are picking out balls, okay, that will be 5 plus 3 plus blue, which is the total number of balls. So we have 5 plus 3 plus 4, and that will be 5 plus 3 is 8 plus 4, that is 12. Okay, and then we are told that it is one after the other. That means we need to look at the probability of picking a first red ball, and how many number of red balls do we have here? 1, 2, 3, 4, 5. So we have 5 over 12. Okay, and then we are told one after the other, meaning that after taking out that first red ball, this is out already. What do we have now? We have the total possible outcome to now be 11. So after that, the possible outcome for second, this is for first, will be the number of red balls is now 4 plus the 3 green balls plus the 4 blue balls, and that will be 11. And then the probability of picking a second red will now be, how many reds do we have remaining? 4 over the total 11. So the probability that the girl takes away 2 red balls one after the other will be the product of these two. So we have 5 over 12 multiplied by 4 over 11, and 4 can go here 1. 4 in 12 is 3. So we have 5 times 1, that is 5. 11 times 3, that is 33. So 5 over 33 will be the solution for this question in this particular case. In this question on set theory with Venn diagrams, we are told that in a class of 80 students, so we can say the number of students in our universal set is 80, okay? 3/4 study biology, so the number of those who are studying biology is 3/4 of 80, okay? Because the 3/4 of this 80 is studying biology, and if we are cutting that, 4 in 80 is 20, so we have 60 to be the number of students studying biology, and 3/5 studying physics. So if we say P is physics, that would be 3/5 of 80, and if we cut 5 in 80 is 16, so 3 times 16, that is 48. Then if each student studies at least one of the subjects, that means that there is no student studying neither biology nor physics. At least students will need to offer at least one of the two, okay? So we have to draw a Venn diagram to illustrate the information, and then to also get how many students study both subjects. So I have this particular template for our Venn diagram, and if I call the student that study both, if I call that X, the biology already you have been told is 60. So here, those who study biology alone will be 60 minus X. And physics we have been told is 48. So those who study physics alone will be 48 minus X. While X represents the student that study both biology and physics. So I can say number of biology and physics is X. Okay, so that is the key point for us to note here. Okay, and then looking at this particular question, what we need to do is that since we have the total number of students to be 80, the addition of those who study biology alone, and those who study biology and physics, and those who study physics alone will culminate into 80. So we can just say for this particular question, if we add everything, 60 minus X plus 48 minus X is going to give us 80, which is the total number of students that we are looking at generally. Minus X and X will cancel out. 60 plus 48, that will be 108 minus X is equal to 80. And if you rearrange, X will be 108 minus 80, and that will be like 100 minus 80 is 20. Then with the 8, we have 28 students. So 28 students are those that study both subjects that we identified as biology intersect physics. Okay, so here our Venn diagram is question number 1. The number of those that study biology and physics is question number 2. We now need to get the fraction of the class that study biology but not physics. Okay, so now in the third question, we have to find the fraction of the class that study biology but not physics. That means we are looking at a number of those who study biology but not physics. We mean complement of physics. Okay, and then we are dividing that over the total number of students in the class, and that particular region that we are looking at will be nothing but this region here, and that will be this region here, okay, divided by the total of the student, because these are those who study biology only. You can see physics is not included. Those that study physics only, and those that study biology and physics, we have excluded them. So it is this shaded region that we are looking at, and that is nothing but 60 minus X. So if you want to reflect it, you can just say this is nothing but 60 minus X, which you already got to be 28, divided by the total number of students, that is 80. If you are just to do this, this will be 32 over 80, and for 32 over 80, we have 16 in 32, that is 2, 16 in 80, that is 5. So the fraction of the class that study biology but not physics is nothing but 2 over 5. And with that, we've been able to look holistically at this question, interpret the question correctly, and give the answer as requested. All right. In this question on commercial mathematics, we are told that Johnson and Jokato Limited owned a business office with floor measuring 15 meters by 8 meters, and that floor was to be carpeted. Okay, now the cost of carpeting was 890 Ghanaian cedi per square meter, and if a total of 216,120 Ghanaian cedi was spent on painting and carpeting, our man needs to find how much was the cost of painting. So we can look at that floor just as represented, and we have it as 15 meters by 8 meters. Now, from the information that we are given, we have been told that the cost of carpeting was 890 per square meter. So that is per square meter. But now the area of the floor that we are looking at in this particular case was given as 15 meters by 8 meters. So if you are to compute that, that will give us, let's look at our calculator, 15 times 8. So that is 120 meters square. So this is 120 meters square. But we are told that the cost of carpeting was 890 Ghanaian cedi per square meter. Now, for all this 120 meters square, we need to multiply by this 890 Ghanaian cedi. So we can say that carpeting cost, the cost for carpeting cost is going to be this 120 that we just got multiplied by 890. And if you are to evaluate that, you can just say our answer times 890. Okay, so that's 106,800. So you add that to be 106,800 Ghanaian cedi. So that is the cost for carpeting. We were told that a total cost spent was 216,120 Ghanaian cedi, which was spent on painting and carpeting. So the cost of painting will be this minus what we got for carpeting. Okay, so we can just say painting plus carpeting. The two of them, they cost a total of 216,120. Okay, now for us to be looking for the price for painting, cost of painting, we now have to be that total, which is 216,120, minus the one for carpeting, which you got as 106,800. So if you are to just compute this from our calculator, so we can say this is our answer, but we have 216,120 minus the answer that we got, and that will be 109,320. So we have it as a Ghanaian cedi 109,320 Ghanaian cedi, and that is the cost of painting for that particular office that was gotten by Johnson and Jokato. All right. If you are preparing for your WAEC NECO GCSE exam, you should know that graph is a question that you cannot miss in any way. And so, we want to look at this question on the graphical solution to quadratic and linear equation. And we have been asked to copy and complete the table for the relation y is 2x squared minus x minus 2 for this range of value, which we have been given the table that is pre-conceived already with some values inputted there. And then we have to use a scale of 2 cm to 1 unit on the x-axis and 2 cm to 5 units on y-axis to draw the graph for that range of values. And then on the same axis, we have to draw the graph of y is equal to 2x plus 3. And then we will use the graph to find the root of this particular equation, and then for the range of values for which this equation is less than 0. So before we just go ahead to start solving, let me just say something about this particular equation. If you look at that equation and what we are asked here, okay, originally we are given y to be 2x squared minus x minus 2. Now, as a rule of thumb, whatever subsequent question is coming from your graph, you should make sure that you tailor it to this particular equation. And in the very first case, look at what we are told for this particular equation. We are told that 2x squared minus 3x minus 5 is equal to 0. So for me to try and reflect y out of it, if I just take y out of this equation, I can say this is 2x squared minus x minus 2, okay? But what is remaining after taking this y out? We can see that we still have minus 3x, but we have taken minus x out, so we have minus 2x, such that minus x and minus 2x will be minus 3x, okay? And then, again, for the third term, we have taken minus 2 out, but what we have originally is minus 5. So if we have minus 3, minus 2 and minus 3 will be minus 5, so this is equal to 0. This is the manipulation that we need, and you can see that this in bracket is y already, so I can say I want to just write that as y. Then when minus 2x moves to the other side, it's going to be 2x. When minus 3 goes to the other side, it becomes plus 3. So the root of this equation is meaning that you should find the point where y, which was given as 2x squared minus x minus 2, is equal to this new equation 2x plus 3. So definitely you are going to have maybe something like this for the quadratic, and then something like this for the linear. Then this point of intersection, you can see we have the quadratic having that U shape, and then we have the linear having a straight shape. This point of intersection is what you need to trace to the x-axis, and that will be the root of the equation, okay? And then, interestingly, the second one, the range of values for which 2x squared minus x minus 2 is less than 0. So, most likely you will have something like this also. And then let's say this is the x-axis, and hypothetically, let's say this is the y-axis. So now, for the range of values for which 2x squared minus x minus 2 is less than 0, looking at this graph, on the positive, here, that is greater than 0. On the negative, this is less than 0. So, the region of interest will be this region, talking about the quadratic, and then the range of values for x, for which that is equal, will be from here to here. So, inherently, what they're also asking is like, look for the root of the equation, okay? Because at that root, the graph is going to move on to the negative side, which is less than 0. So, those are the things that we need to do, but our understanding is first and foremost key. And now that we understand, we can go ahead to say we want to solve the question as appropriate, which we are going to start doing with the table of values, okay? So now I prepared the table of value ahead, and I just put in all the values that we'll be needing as showcased in this particular case. Already we have been given the values of x, so that is reflecting on the very first row. These are the values of x, okay? We have also been given some values of y for the quadratic, and these are those values, 19 minus 2 and 26. But looking at the question, we have minus 2 as a constant. Minus 2 is not going to change its value at all, so that is there. But then this is for the quadratic, so this here is for the quadratic. Y is equal to 2x squared minus x minus 2. Okay, this is for this quadratic. But that's not the only equation we have. We also have this linear equation, y is equal to 2x plus 3. So this will amount to y is 2x plus 3. So those are the two values that we have. And already we also note that 3 is a constant. So that value is not going to change, but we need to evaluate the value of 2x. So I'll just do maybe just 2 or 3, and then the other ones, so then you can also get your hands dirty. You don't learn by just watching, you also practice. So you do the other ones by yourself, because I'm just going to increase my speed and you'll not be able to see that. So in the first case, when x is minus 4, x squared will be 16, 2 times 16 will be 32, and make it a point of duty that don't forget your 2. Ensure that you include it in your equation, okay? When x is minus 4, minus x will be minus 4. The negative signs will multiply to become plus, so this will be 4. And the addition of this particular 3 values will give us the value of y here. And for us to do that, we'll say 32 plus 4 is 36 minus 2. That will be 34, okay? And then in this particular case, you can just use it to check if you are on the same track, and we're also going to get the answer correctly, okay? So minus 3 raised to power 2 is 9. 2 times 9 is 18, so we have 18 here. Minus x will be minus 3, and that will be 3. So 18 plus 3 is 21. 21 minus 2 is 19. So we are on track. That is quite correct. And then let me just do this as the last point, and I will just fill in the other ones. Minus 2 raised to power 2 is 4. 2 times 4 is 8. Then minus 2 will be 2. 8 plus 2 minus 2 will be 8. Okay? And I can just speed up now since you get the hang of it. Okay? Now, in looking at the values of y that we just got, one thing I'm noticing was that this is not symmetrical. Generally, most of the times, with the values that you have, by the time you have your turning point, the values to the left and the values to the right, they'll just be reflective of one another. Like maybe you have, like if minus 2 is the turning point, then you have 1, then this will also be 1. You have 8, this will also be 8. You have 19, this will also be 19. You have 34, this will also be 34. That means that for this particular set of values, we are not having the turning point at all. The turning point is not included here. So students, just note that, so that by the time you are putting in your point on your graph, you notice that you need to be consistent with what you need to do. Okay, so we just extrapolate the values for this particular linear graph also, and then 2x will just be 2 times the value of x that we have. 2 times minus 4 will be minus 8. Minus 8 plus 3, this will be minus 5. 2 times minus 3 will be minus 6. Minus 6 plus 3, that will be minus 3. And I can just speed up now since you get the hang of it, okay? Now, with this value, you can also notice that there is a consistency of an incremental value of 2 in this particular case. So, it's going to actually be like that because it's a linear graph. It's going to be straight. It will be consistent in its differences. So, this is our table of value now, and this is what we are going to use to actually plot our graph. All right. So here is our table of values that we just extrapolated out. And the questions we have to solve is the root of 2x squared minus 3x minus 5, which I have explained that is the point at which the quadratic is equal to the linear. And you can see here, if 2x moves to this left-hand side, it will become minus x minus 2x, which is minus 3x. And if 3 moves to the left-hand side, it will become minus 2 minus 3, which is minus 5. So we need to look at the point of intersection of the two graphs. And then for the range, we also solve that appropriately. But now, we need to see how we can extrapolate our values for x and y on the graph. We have been told 2 centimeters to 1 unit on the x-axis. Here, on the x-axis, 2 centimeters to 1 unit. And on the y-axis, we have been told 2 centimeters to 5 units. Now, for the x-axis, we don't have any problem because 1 unit, this is also 1 unit. We just need to look for means to actually locate that. So if you want to put that maybe here and just look at the center, let's say this is our origin. So for x we have 1, 2, 3, 4, and then minus 1, minus 2, minus 3, and minus 4. And you can see that is quite good. Now for the y-axis, 2 centimeters to 5 units, meaning that between 2 centimeters, between this point and this point, this is actually 2 centimeters. And those 2 centimeters is comprising of 10 small boxes. So, inherently, we are saying 10 boxes should be 5 units. 10 boxes, we are saying it is 5 units, okay? Then if that's the case, what is 1 box? What is going to be the unit of 1 box? That unit of 1 box will be, here we just need to cross multiply, okay? So we are going to have it as 5 times 1 divided by 10. And this is just 5 here, 1, 5 here, 2. So this is 1 over 2. So each of the small boxes is going to be 0.5 units. I'm doing this because I need to extrapolate numbers that are not going to lie directly on the tick boxes, because 5 units, we only have 5, 10, 15, 20, 25, 30, and co. But here, look at this. We are even having 34, 19, 18. We don't even have anything that is a multiple of 5. So we need to know how we can appropriately adjust that. So if I just want to read it off and show it on the graph, I would say for me to get each incremental value, so here this is 0, and then reading on the vertical axis, this will be 0.5. So this is 1, this is 1.5, this is 2, this is 2.5, this is 3, this is 3.5, this is 4, this is 4.5, and this will be 5. So I can have 5, 10, 15, 20, 25, 30, 35. Okay, so the point at which I'm taking the graph is quite good. That is quite interesting. I think that can be useful. I can use this as my origin. I didn't mean that my 35 is eating up, then I know that I need to move my graph down. But I think with this, it's quite okay. I can just input that and I will draw my vertical and horizontal axis and put in the scale and we'll go ahead to solve the question, all right? So we have our graph prepared already with the scale that we're given and placed on the graph in such a way that everything will be centralized as appropriate. And then want to extrapolate those values. In this first case, for the quadratic equation, when x is minus 4, y is 34. And I've been able to establish the fact that now, in this case, this is 4, okay? 34 will just be 1 unit before 35. And 1 unit will correspond to 2 boxes because each of the small box is 0.5 units. So we are looking at something here to say this point of intersection is a point of interest for us when x is minus 4 and y is 34. So we can note that here. Okay, and again we can look at the value of x minus 3 and y 19. 19 will also be 2 boxes before 20. So we have somewhere here. So that point of intersection is also our point of interest, which we will note now. So here, that is 19. And then since we get the hang of it, you can just go ahead. Minus 2 and 8. It will just be... You can just get the other ones. I will speed up the video now. Okay. So if you do that correctly, you are going to have something like this as the curve that is joining all of your points. Okay. And then as good as it gets, you can also do the same for the linear graph. Like here, when x is minus 4, y is minus 5. You can see this is minus 4 here. And then we can look at minus 5 here. And this should be quite straight because it's going to even be a straight line graph. Okay, so we can say this is our point of interest. And when x is minus 3, y is also minus 3. Minus 3 will just be, mid here is 2.5 plus 1 box. That will be minus 3. That will be like here. Okay. And then we can just continue. So when x is minus 2, it is minus, y is minus 1 here. When x is minus 1, y is 1. This is exactly the same point. And interestingly, here, that is the point where the value of y for the quadratic and the value of y for the linear, they are overlapping. So that is still the same one that we have notched initially. You can just get the other ones. I will speed up the video now. Okay. When x is 4, y is 11. So that is 11. And then we can say we want to join them all with a straight line, just passing through all of them. And then I think this is as good as it gets. Okay. So that is our graph. And as a rule of thumb, it's just good that you label, yeah, this is the quadratic, y is 2x squared minus x minus 2. And this is the linear, y is equal to 2x plus 3. All right. So in the first case, where we are asked to find the roots of the equation 2x squared minus 3x minus 5, which we have explained to be the point of intersection of the quadratic and the linear graph. You can see here this point, and that is minus 1, okay? And here this point, but if we trace that down, we are going to see that it's going to land directly between 2 and 3, and that is 2.5. So here is down on minus 1, which we even got from the graph initially. So you can just say the roots of that equation are x is equal to minus 1 and x is equal to 2.5 as seen from the graph. Okay, so student, you can still go ahead to verify this answer by solving for this question, maybe by factorization method or formula method, to get the root of that. But here, let me just make use of the calculator to say I want to equate the two equations together, like I have 2x squared minus x minus 2 is equal to, that equal to will be alpha calc, okay, is equal to 2x plus 3. So I want to solve for this. So I'm using shift calc, that is solve. And I want to solve for x, starting its iteration from 0. No, I have two values, one in the negative, one in the positive. So I will take minus 4 as the first point to start its iteration. Start from minus 4. What is that going to give me? Okay, x is minus 1. That is for this. If I still want to solve, I want to use 4. Okay, let me just use 3 now. I want to use 3 as the starting point for its iteration. Then what is that? So you can see 2.5 and minus 1. And that is giving me the hint that I am quite on track with this solution that I've got. But that's not all. For the graph, we also have to find the range for which y is less than 0 for the quadratic. And in that particular case, if we are to look at it, we can look at this. These are the points where y is actually less than 0. You can see up here we have the positive values of y. Y is greater than 0 there. Down here we have the negative values of y. Y is less than 0. And then we are asked to find the range for that particular case. If you zoom in, you can see that here and here, those are the points that we have as the range for which y is less than 0. So we can say we want to get the particular range as shown on the graph. Now, on the horizontal axis, we have 10 boxes that are amounting to 1 unit. So each of the boxes is 0.1 unit. And here, we have 2 boxes just before 1. So that will be 1 minus 2 of those boxes, which will be 1 minus 0.2. So that will be minus 0.8, negative because it is to this side. And here, I can see it's just between 1, 1.1, 1.2, and 1.3. So I can say, let me just say this is x less than or equal to 1.25. Okay? That's what I'm seeing as that. But actually, this is also the root of the quadratic equation where it's cutting the x-axis. And we can also say we want to solve for that. We can just say we have our equation, okay, 5. We want to solve it is a quadratic, that is amounting to 3. And what is the first term? That is 2. And then the coefficient of x, that is minus 1. And then the constant c, that is minus 2. So you can ask the calculator to solve that. And then the very first solution, x1, this is 1.28. That's quite interesting. And you know, we got 1.25, close to 3, okay, and then the other one, this is minus 0.7, which is approximately minus 0.8, and then it's also giving us the minimum value of x and the minimum value for y. We are not concerned about that here, but we have just verified that yes, within this range of values that we have, we're actually quite on track, and our solution is done and dusted. So students, you can do well to practice on this type of questions a whole lot, particularly because there are sure bankers in the exam, and proper preparation like this will prevent poor performance. We hope this will be useful for you and wish you the very best. All right. In this question on triangle and measuration, we are told that in triangle PQR, angle PQR is 90 degrees if its area is 216 centimeters square and the ratio of the side PQ to side QR is 3:4. We are to find PR. Okay, now this is quite very interesting, but students, first and foremost, you should be able to interpret this question so that all that we need to put and how we need to get, we need to define it. Okay, in the first case, we are told that PQR is 90 degrees, so that is rendering this triangle as a right angle, and because Q is a point at which we are taking that angle, that's why it's in the middle here. So we can say this is our point Q. It is at the right angle there at point Q. Then we have PQ and QR to be ratio 3:4, meaning that PQ is shorter. PQ is the one that is smaller. QR is longer. So I can say R is here, so that QR is longer. PQ will not be the other one. But what we are asked to find, look at this. It is the side PR, this particular side. If I call that Q, since it's opposite Q, let me call this Q. That is what we are asked to find. Now, from this question, we're also given the area to be 216 centimeters square. Now, if we can relate that area to these sides, because we know that generally the area of a triangle, particularly as relevant in this case, will be half base times height. So the base will be QP, the height will be QR. Okay, so we can get those two. We can use Pythagoras Theorem to get the side Q. Okay, but from the question, we are given PQ over QR to be in the ratio 3/4, such that if I want to just make it flat, PQ is going to be 3/4 QR. Okay, now since it is 3/4 QR, do I want to be working in QR? Let me just call it X. Let me just say if QR is X, I can say PQ will be 3/4 X. Let QR, let that be X. Then PQ will be 3/4 X. So here, QR, if this is X, QP or PQ, that will be 3/4 X. But before we move on, we are given the area. So that area that we're given as 216 will now be 216 is equal to 1/2. What is my base now? The base is QP, which is 3/4 X. And what is my height? That is QR, which is X. And with this, I can just say, that means from the right hand side, X and X will be S squared. We have 3/8. So we have 216 is equal to 3/8 S squared. So S squared will be 216 times 8 divided by 3. Okay, so we can solve for this. 216 times 8 divided by 3. So this is 576. What's the square root? Square root of our answer, 24. Okay, so this is 576, and X will be the square root of 576, and that will go to be 24 centimeter. Okay, let me just move my work area to create more space. Okay, so having gotten this, you can make use of the Pythagoras Theorem to help us evaluate the value of Q, which is PR, that we are looking for. And Pythagoras Theorem is telling us from this triangle, what we are going to have is that Q square is equal to S square plus 3/4 H square. Okay, that means that the square of Q will be S square, which is 24 raised to the power 2, plus 3/4 times 24 raised to the power 2. Okay, so that will be 24 raised to power 2 plus here we can cut 4 here 1, 4 here 6, 3 times 6, that's 18 raised to power 2. So if you are to input that in the calculator, we are going to have 24 raised to power 2 plus 18 raised to power 2. So this is 90, okay, so this is 900, such that in that case, Q is going to be the square root of 900, and the square root of 900 is nothing but 30 centimeters, which is the value of the line PR that we are asked to find originally. So we didn't need to fret, we just need to interpret our question correctly, represent them in a diagram to just help us visualize it, and then put in all the parameters that we have, so that at the end of the day we can find the line PR, which is the hypotenuse, to be 30 centimeters by making use of the Pythagoras Theorem. All right. In this word problem, we are given that the present ages of a man and his son are 47 years and 17 years respectively. So that inherently means that for the man, his present age is 47, and for the son, his present age is 17, okay? In how many years would the man's age be twice that of his son? Meaning that if we add some years, let's say x, to the age of the man, we are looking for a time period which is x, that the age of the man, which will be his present age now 47, plus that number of years we are looking at, will be equal to 2 times the age of the son, and the age of the son at that time will also be 17 plus x. Since is a futuristic year that we're going to add to their present age, that's why we have 47 plus x and 17 plus x. But we are being told that at that particular year, the man's age will be twice that of his son. That's why we're multiplying his son's age, the new age, that's why we're multiplying it by 2. So all we just need to do is to solve this question, and we'll get that number of years, which is x, okay? So if we just open up this bracket, we have 47 plus x is equal to 2 times 17 is 34, and 2 times x is 2x. All we just need to do is to move the like terms together, and in this case, we will have 47 minus 34 is equal to 2x minus x, okay? Then 47 minus 34, this is 13, and 2x minus x, that is x. So the number of years when the father's age will be twice that of his son is nothing but 13, and our work is done and dusted. In this question on measuration, we are told that in the diagram, PQRS is a trapezium and QR is parallel to PS. So we have QR parallel to PS. Okay, that's why we have these double arrows on both of them. Then U and T are points on PS, so that PU here is 5 centimeters, QU is 12 centimeters, and angle PUQ is the same as SCR, that is a right angle. So PUQ and then STR, you can see both of them are 90 degrees. Now, if the area of triangle PQR, this triangle here, the area is given as 20 centimeters square, we're to find, correct to the nearest whole number, the perimeter and the area of the trapezium. Wow, okay. So looking at this, ideally, the perimeter of this trapezium is going to be the sum of all of the sides. And if you want to append that, instead of just using all this P, Q, Q, R, I want to peg it as, let's say, this is A, this is B, this is C, this is D, this is E, and then, okay, let me call this F, okay? So it's the addition of A, B, C, D, E, and F that will give us the perimeter. So I have this as A plus B plus C plus D plus E plus F. So I'm noting that. And then how am I going to get the area? The area of this is going to be 1 over 2 multiplied by the sum of the parallel sides, which is QR and PS. So that will be sum is B. But for the PS, we have it as F, E, and D, or D, E, and F, plus D plus E plus F, multiplied by the height of the trapezium, that is QU. Okay, so we call this G. Let me just use red so that I don't confuse this. If I call this G, okay, that G is actually also 12 because it is the same QU, RT, they are the same. So that area of the trapezium will be half multiplied by the sum of the parallel sides. One of the sides is B, QR. The other is D plus E plus F, which is PS. So multiplied by the height. The height is now RT, or I can say multiplied by G. So the mandate I have before me here, first and foremost, is to find all of these unknowns from A down to E, because I now have F is 5 centimeters, G is 12, but I need to find A to E. That is the mandate that I have before me, and the steps are going to be taken are going to be geared towards solving that, such that once we can get that, we can bring in those values here and find the perimeter and the area as appropriate. Okay, so students, let's kick in and see how we can solve this. In the first case, A, from this particular triangle PQU, we can see that it's a right angle triangle. If we have considered the angle at P here, 12 will be the opposite, 5 will be the adjacent, A will be the hypotenuse. So we can use Pythagoras Theorem to find A, to say A square is going to be 12 square plus 5 square, and that is 144 plus 25. So A as the first parameter will be 144 and 25, that will be 169. A will be the square root of 169, and that will be 13 centimeters. Okay, our first mandate is done. B, how do we find B? Looking at this question, okay, interestingly, you can see that B is also E. We are given in the question originally that the area of triangle PQR is 20 centimeters square. So PQR, that area is 20 centimeters square. But interestingly, if you look at this very well, and let me just say this particular side A, if I draw another line parallel to that particular side A, just something like this, okay? If I do that, and here, what can I call this now? Let me just call this point A, okay? This particular parallel side, which is also A, renders this shape PQRA to be a parallelogram, okay? This is a parallelogram, and we know that normally the area of a parallelogram, this is interesting, the area of a parallelogram is this height, 12, multiplied by the base. So that's going to be B multiplied by H, or that's G also, B multiplied by G, where B is the base and H is the 12 centimeters. But interestingly, that's not where I'm really going. The area of the triangle PQR is going to be half of the area that I just defined. That is just a normal theorem postulated when you are looking at a triangle and a parallelogram. You can see ideally, if you look critically, that that triangle is actually half of the parallelogram. So it's dividing the parallelogram into two triangles, and the areas of those two triangles are going to be equal. So inherently, what I'm saying is that for this particular stuff, we have it that the area of the triangle PQR, which we have been given as 20, that 20 is going to be 1 over 2 multiplied by, is this B that we are looking for, okay? Then multiplied by G, which is the height of that parallelogram, that is 12. So B multiplied by 12. So from here, we can see that our B is 2 times 20 divided by 12, okay? So if you want to use our calculator for that, we have 2 times 20 is just 40 divided by 12, and that will give us, okay, 3 points. That dash on top of 3 means that it is continuous. So it is, this is B, interestingly, which is also the value for E. Okay, this B, QR, and UT, they are the same. That is nothing but 3.333 centimeters. Okay, that's quite good. Now we can move on to C. For us to find the value of C, we can see that we have triangle from the triangle SRT. We can make use of SOHCAHTOA, and SOHCAHTOA will help us to effectively solve this, because we can see that from this diagram, if you consider this angle 50 degrees, we are going to see that for that angle, this G or 12 is the opposite, C is the hypotenuse, then D is the adjacent. Then if we can make use of those trigonometry identity, we can find the value of C and D as appropriate. In the first case, if I say sine 50 will be opposite, which is 12, over C, that is the hypotenuse. So I can have sine 50 is what? Opposite, which is 12, over the hypotenuse, which is C, so that C will be 12 over sine 50. And if I use my calculator, 12 over sine 50, I have 12 divided by sine 50. That's going to give me 15.6648. Okay, 15.665. So this is 15.665 centimeters. And that's not all. I also have d. I can make use of maybe Pythagoras Theorem to say c square is 12 square plus d square. But I still want to make use of the trigonometry identity so that I will just use the value of 12, that is a whole number, and given already to evaluate d. So for d, it is adjacent. Then this 12 is opposite. That means I need to use tan, opposite over adjacent. So I can say again, tan 50 is the opposite, which is 12, over the adjacent, which is d. And then that will render d to be 12 over tan 50. Okay. And then that d will be, so this is c and this is d. Okay. That d will be, I can just change this to say I'm deleting this and putting tan. 12 over tan 50, 10.069. So this is 10.069. Okay, again, the unit is centimeters. What else? We are looking for our E. Okay, we have gotten E to be the same value as B, and that is 3.333 centimeters. And F, we have been given as 5 centimeters. All right, so now we are good and fine. We can say holistically now, we can look at this question, find the perimeter by adding all of the sides, and then find the area by using this formula as we have postulated before. Now, for me to do that, let me just put all the values of these parameters appropriately on the diagram, because I'll need to clean my board. A is 13, B will got to be 3.333, which is the same as E, 3.333. C will got to be 15.665, and then D will got to be, this is 10.069. All right, okay. So let's try and find our question set now. In the first case, we are asked to find the perimeter, and we have said perimeter is the sum of all of the sides. So we can put in those sides. The perimeter will be 13 plus 3.333 plus C 15.665 plus D 10.069 plus E 3.333 as discovered before, then plus F, that is 5. So I just need to add all of this in the calculator, and that will give me, in the first case, A is 13, plus B is 3.333, plus C is 15.665, plus D is 10.069, plus E is 3.333, plus F, that is 5, and that's going to give me what? 252 over 5, and okay, this is 50.4. So 50 is 50.4. But looking at the question, we're asked to find it correct to the nearest whole number. 4, we need to round down to 0, and that will make sure that our answer is nothing but 50 centimeter as the perimeter of this particular trapezium. Okay, quite interesting. And then in the second case, we are saying that the area of that trapezium is nothing but half multiplied by the addition of the parallel sides, which is QR and PS, that we have found to be B plus D plus E plus F. So we want to put that B is 3.333 plus D is 10.069 plus E is 3.333 plus F, that is 5, multiplied by G, which is QU or RT, and that is 12. Wow, okay. So I'll just do the one in bracket first, okay? So let's do that. So I have 3.333 plus 10.069 plus, again, 3.333 plus 5. What is this giving me? It's 21.735, 21.735, then multiplied by 12, okay? So I can just cut here. Let's say this is 2 here, 1, 2 and 12 is 6. So what I'm having inherently is 21.735 times 6. So my initial answer multiplied by 6. And this is 130.41. 130.41. But if you recall, we have to find to the nearest whole number. So again, 4 will round down So this will be 130 centimeters square. Wow. We didn't need to fret. We just need to be consistent with how we are going to get all of the sides of this trapezium, and after getting them, use the formula for the perimeter as the sum of all those sides, and then the formula for the area as half multiplied by the sum of the parallel sides, then multiplied by the height of the trapezium, and we got our answer here by making use of postulate of the area of the parallelogram as compared to the area of the triangle, and then SOHCAHTOA from trigonometry, and we got our answer out. And fine, what a question, right? In this question on bearing and distance, we are told that a cottage is on a bearing of 200 degree and 110 degree from Dogbe's and Manu's farms respectively. Now, if Dogbe walk 5 kilometers and Manu 3 kilometers from the cottage to their farms, we are to find correct to two scenario figures, the distance between the two farms, and to the nearest degree, the bearing of Manu's farm from Dogbe's farm. So let's look at this critically. Now, we are told that the cottage is on a bearing of 200 and 110 from Dogbe's and Manu's farm. So we need to take the bearing of 200 from Dogbe and 110 from Manu. So in the first case, we want to locate 200 degree. We can say we want to draw our cardinal point just like this, okay? And then we have our north, our south, our east, and the west. And we will notice that 200 will be in the third quadrant because north to south is a straight line. That's 180 degrees. So 200 will be just a bit off of that. So we can look at a scenario coming like this. So I can say what I'm having from the north to this inclination is 200 degrees, okay? And then in addition to that, we're also told that from Manu's farm, it is 110 degrees. If we look at 110 is going to be in the second quadrant. Let's just use this as a reference. North to east is 90 degrees. So 110 will just be 20 more than 90. That means it will be something coming in this direction, okay? But we are not taking it from Dogbe's farm. We have to take it from Manu's farm. That means that Manu's farm should be located somewhere here, okay? Somewhere here, so that this inclination can just come to meet this one as shown in the diagram. So that's what we are going to do to locate Manu's farm. You can just say I want to take that cardinal point, just say from here. All right. Again, I want to have my north, south, east, and west. Let me just leave that because I'll be including that in the diagram. Then I want to join this point to say this should come just like this, which I can draw the bearing to say from the north to that inclination is 110 degrees. Then I can say I want to just finish up with the diagram by just drawing this line to join and finish here. And then I can label, okay? Now, we are taking the bearing from Dogbe's farm is 200. So this is where we are taking the 200 from. That is Dogbe's farm, D for Dogbe. Then M for Manu. This will have to be M, okay? And then we are talking about the cottage, is the bearing to the cottage. So this we can label as our C. So for us to finish up the diagram, we can just include the distances. Dogbe walked 5 kilometers to that cottage. So this is Dogbe. This is the cottage. So this is going to be 5 kilometers, okay? And then Manu walked 3 kilometers from his own cottage to the farm. So this is 3 kilometers. And you can see how I use a shorter distance from Manu as compared to Dogbe, and then using the relative positions of the bearings, I'm able to locate this as appropriate. So let's try and solve this and see what we can use to get the distance between the two farms. Manu's farm, M here, to Dogbe's farm, D here. Okay, so since that distance, MD, is opposite C, I can just call this C. Okay, so 5 kilometers will be small m, 3 kilometers will be small d. So let me just leave this at this. So we have this question and it's giving us a triangle already. I want to find this particular side, but we need to get any of the included angles so that we'll be able to solve this effectively. Now, looking at this diagram and what we have, we can say at point C, we can get the angle at this point C, because looking at this particular point M, we know that from north to south is 180 degrees, is a straight line, and angle on the straight line is 180. So here, that will be 180 minus this 110. So that will be 70 degrees. Okay, but we are not going to be stopping there, because we know that from this particular point M to point C, we can take this particular angle and bring it down to C, okay, and also take it up to say this angle here that we are looking at is also 70 degrees, because it is alternate to this 70 that we got by deducting 110 from the angle on the straight line 180, which is from north to south. Okay, and then interestingly, from D also we can see that here we can have something like this. At D we can also have this straight line from the south and then incline it to this particular point C again, and then again we can take it up to see that this angle here, which will now be 200, that is from north to the inclination of C from D, minus 180, which is from the north to the south. So this angle is 200 minus 180, which is 20, and then this place is also going to give us 20. And as interesting as that gets, we are seeing that at this particular junction, at this point C, what we are having is inherently nothing but a right angle. So this is just 70 plus 20, and the addition of the two is going to give us nothing but a right angle, 90 degrees. So it is the breakdowns like this that will help us to holistically solve our question, and that renders the triangle MDC as a right angle. So what we are having is that triangle MDC is nothing but a right angle triangle, and if we can get this, then we know that we can postulate just the two theorems to help us solve right angle triangle. First, the trigonometry identity SOHCAHTOA. We can use SOHCAHTOA, and then we can use the Pythagoras theorem. Okay, the SOHCAHTOA plus Pythagoras that can help us to solve questions like this when we have a right angled triangle. So let's see how we can use that to solve this particular question. In the first case, we want to find the distance between the two forms, and we have said that is C, distance from M to D. And by Pythagoras theorem, we can say that C square is going to be D square plus M square. And I've said D is this particular 3 kilometers, which is facing the vertex D. And M is this particular 5 kilometers, which is facing the vertex M. So that means I'm having C square to be nothing plus, what is D square? That is 3 square plus M square, that is 5 square. So C square is 9 plus 25, which is equals to 34, and then I can say C is equal to the square root of 34, and then C, which is distance between the two farms that we are looking for, is going to be, we can bring our calculator to solve this. Okay, the square root of 34, this is 5.83095, let me say 5.83, so this is 5.83, but from the question we are asked to get this to two significant figures. Okay, so we can say approximately two significant figures, which means that we need only 2 digits. 5 is the very first one, we need to take that. Now to consider the second digit, we need to look at the third or the extra digit and see if we need to round it up or round it down. 3 is not up to 5, so we round it down to 0, and it does not take effect on 8 at all. So this is approximately 5.8 kilometers as the distance between the two farms, which is C. Okay, so that is the very first thing. In the second case, they are asked to find, to the nearest degree, the bearing of Manu's farm from Dogbe's. So this is Dogbe's farm. We need to get the bearing of Manu's farm from Dogbe. Already we have seen that from Dogbe to the cottage is 200. If we can get this particular angle, let me call that theta, we will see that the bearing of Manu's farm from Dogbe's farm will be 200 that we got initially plus that theta. Okay, because here we are starting from the north, we get to the bearing of the cottage from Dogbe's farm, and then add theta to it to get to the bearing of Manu's farm from Dogbe's farm. So that bearing that we're asked to find is going to be 200 plus theta. So that is what we are looking for. But for us to get theta, since this is a right angle triangle, if I'm to consider this part, okay, we are considering this angle theta, we have the opposite to it, which is 3. We also have the adjacent to it, which is 5. So what is relating the angle, the opposite, and the adjacent? That is tan. So we can say from here, tan theta that we are looking for is equal to opposite, which is 3, over the adjacent, which is 5. So that is equal such that theta will be arctan 3 over 5, and in that particular case, our theta is going to be, what's arctan 3 over 5? That will be arctan 3 over 5 is 0.6. Okay, so we have this as 30.9637 or 964. That's 30.964, such that the bearing that we are looking for is 200 plus 30.964. And if you had this, that would be 230.964. But again, we are told that we are to get this to the nearest degree. Even if you are not told to get that to the nearest degree, you need to always note that bearings are only given in 3 digits. Even if it is 2, maybe like it is supposed to be 70, you need to add 0 in front that say it is 070 degrees, okay? And you don't say 70 degrees, say 070 degrees, okay? So for this particular question, we are going to round this up, and we can see that 9 will round up to 1 and add to the initial number, such that that bearing will be 231 degrees. So these are the two answers that we're supposed to get. Distance between the two farms is 5.8 kilometers, and the bearing of Manu's farm from Dogbe's farm is 231 degrees. And with that, we've been able to solve this question by first interpreting and getting our diagram correctly and making use of SOHCAHTOA and Pythagoras Theorem, since it is giving us a right angle triangle. If it was giving us a scaling triangle, we could have used the sine and the cosine rule, but yeah, we are good since it's a right angle triangle, and our question is done and dusted. All right. In this question on triangles, we are told that a ladder 10 meters long leaned against a vertical wall, which is x meters high, and the distance between the wall and the foot of the ladder is 2 meters longer than the height of the wall. Our mandate is to calculate the value of x. So if we have this as our diagram as being representing the information that we're giving, the ladder itself is 10 meters long, so we have the length of this ladder to be 10 meters, okay? And then it's leaning against a vertical wall, which is x meters high. So this is going to be x meters, okay? Then the distance between the wall and the foot of the ladder is 2 meters longer than the height of the wall. So here we are being told that it is 2 meters longer than that height. So we have it as x plus 2. And of course, it's going to be a right angle because the wall is ideally inclined at 90 degrees to the floor. So we have to find the value of x. Now, having gotten this, we can see that Pythagoras Theorem is going to help us to solve this question holistically, because we just have the hypotenuse, we have the opposite, we have the adjacent, and we can use the Pythagoras Theorem to solve this, saying that the square of the hypotenuse, which is 10, the square of that 10, is equal to the sum of the square of the opposite and the adjacent. So that will be s squared plus x plus 2 squared. And you can see how I actually included s plus 2 holistically in that bracket. So our mandate is to open this bracket and solve, and we'll find the value of x. 10 squared is 100, so we have that is equal to s squared. X plus 2 raised to power 2 is us having x plus 2 multiplying itself, okay? So this we can just open up to say this is x squared plus x times x is x squared, x times 2 is 2x, 2 times x is another 2x, and then 2 times 2, that is 4. So I want to bring everything together to say s squared plus s squared, that is 2s squared, okay, plus 2x plus 2s, that is 4x, plus 4, okay. If I have 100, if I subtract 100 from both sides, I can say that it will be 100 minus 100 here will be 0, so we can equate that to 0. 4 minus 100 will be minus 96, so this will have to be minus 96 is equal to 0. So this is a quadratic that we can actually solve. But before we say we even want to solve, we can break this down and divide each of those terms by 2. Divide everything by 2, and we have it as s squared plus 2x minus 48 is equal to 0. So for us to solve this, we are looking at a product of terms that is going to give us minus 48 s squared, this s squared and minus 48. Then their sum is going to be 2x. So this is the product, this is the sum. What two numbers can we look at here, okay? I think 8 times 6 is 48. So we have 8 and we have 6. 8x and 6x. We have 8x and 6x. But we need to determine the sign, okay? Since the addition of the two should give us 2x, 8 is a larger number. So we can say 8x minus 6x, okay? Because 8x minus 6x, that would be 2x. 8x multiplied by minus 6x. The plus in front of it, you multiply the minus to give us minus 8x times 6x to give us 48x squared. So 8x and minus 6x is good for us, and we can make use of that to solve this equation to say we have it as x squared plus 8x minus 6x minus 48 is equal to 0. Okay, such that in the first two terms, x is common, so we have x plus 8. Then in the second term, minus 6 is common, so we have x plus 8 again. You need to be careful here because minus 6 times plus 8 is minus 48, so you cannot say minus here. Okay, so once you have gotten that, you can see that we can factor this out to say what we have inherently is the x minus 6 into x plus 8 is equal to 0. And from here, is either x is equal to 6 or x is equal to minus 8. But let me ask you a question. Can the value of x, which is a measurement of distance, can it be negative? It can't, so this cannot be our answer. Then definitely s is going to be 6. And that is why they didn't ask us to calculate the values of x. They only asked us to calculate the value, a singular value of x. And then 6 will be the answer here, and our question is done and dusted. All right. In this question on statistics, we are told that the table shows the distribution of the number of hours per day spent in studying by 50 students. So in the first row, we have the number of hours per day, and in the second row, we have the number of students taking those hours to study. And our mandate is to calculate correct to two decimal places, the mean and the standard deviation as appropriate. So I prepared a table that we are going to use to compute the values that we need, and the formula that we'll be using is here. For the mean, we need to find the summation of the product of the frequency and the data set. And here, the data set happens to be the number of hours, and the frequency is the number of students, okay? So we'll divide that by the summation of the frequency. Then for the standard deviation, we can use this formula here, and we need to find the product of the frequency and the square of the data set. Then we can use them in this formula to solve this. There's another formula that you could have used, in which you'll be subtracting the mean from each of the data set entry, and you'll be finding the square. Students, you can try that out. We have done that type in a number of our questions on our playlist, and you can also check those out. But here, we'll be consistent with this because it just gets us to our final destination quick and fine. So here we have fx to compute, and that means just the product of these values for x and the value for f. And for us to do that, 4 times 5, that is 20, 5 times 7, that is 35, 6 times 5 is 30, 7 times 9 is 63, 8 times 12, that will be 96, 9 times 4 is 36, 10 times 3, 30, and 11 times 5, that is 55. Okay, we can do it to just compute the total of that. 20 plus 35 plus 30 plus 63 plus 96 plus 36 plus 30 and 55. Okay, so this is 365. The summation here, summation fx, that is 365. Okay, here for the frequency, let's just sum that straight. 5 plus 7 is 12, plus 5, 17, plus 9, 26, plus 12, 38, plus 4 is 42, plus 3, 45, plus 5, that is 50. So summation f is 50. Okay, then in that case, we can get our mean out to say the mean is nothing but 365 divided by 50. And if we want to put that into our calculator, the answer that we got last divided by 50, so this is 7.3. Okay, but look at our question. We are told to find it correct to two decimal places, so I can say this is 7.30 hours. Hours because x is our data set. It is the number of hours per day that we are looking at. Good and fine. We can go ahead to now say we want to compute s square. 4 square will be 16, 5 square 25, 6 square 36, 7 square 49, 8 square 64, 9 square 81, 10 square is 100, and 11 square is 121. Okay, then moving on, we can find the product of the frequency and the square of the data set in this particular question. So s square will be 4 raised to power 2, which is 16 that we have gotten here, times 5, that will be 80. So we have 80 here. Then 7 times 25, let me just bring in my calculator. 7 times 25, This 175, and then we just do that for each of those other ones. 100 times 3, that's 300, and then 5 times 121, that will be 605. Okay, so if you are not sure, you can check that. 5 times 121 at 605. Then we can do well to sum all of this entry now. Well, we have 80 plus 175 plus 180 plus 441 plus 768 plus 324 with 300 and finally 6605. Okay, so this is 2873. So the summation here, summation fs square, is 2873, and these are the values that we can use to get our standard deviation. So since we have all of these requirements that we need, we can now say we want to find the standard deviation to be the square root of summation fs square, that is 2873, over summation f, that is 50, minus the square of the mean, 7.30 square. Okay, so this is what we need to compute, and if you want to put that into the calculator, we can have our final answer divided by 50, that is equal to, that's 57.46. So this is square root of 57.46 minus 7.3 raised to the power 2, 7.3 to the power of 2. This is 53.29 minus 53.29, and then we can find this to say what's going to be this value, 57.46, 57.46 minus the answer that we just got. So this is 4.17, square root of 4.17, that's going to give us what? So the root of this answer now, that is 2.042, 2.042. But recall, we are asked to get it to correct to 2 decimal places. So here, 2 will round down to 0. That will not have effect on 4. So we have it as 2.04 hours as the standard deviation for this particular question. And with that, we've been able to solve this question holistically, compute our table, use the formula that is appropriate, and our work is done and dusted. All right. In this question on circle theorems, we are told that in the diagram, PQRS is a circle, and then PQ is equal to QS, and angle SPR is given as 26 degrees, and the interior angles of triangle PQS, this triangle here, okay, the interior angles are given in the ratio 2:3:3, and mandate is to find PQR, RPQ, and PRQ. In the first case, what I want to point out is that when we are told that the interior angles of this triangle PQS are in the ratio 2:3:3, let's identify those angles on this particular diagram. Okay, since line QS is equal to line PQ, that makes this triangle an isosceles triangle. And one thing we notice that for an isosceles triangle, the base angles of isosceles triangle are equal. And what are the bases? It will be this angle here, SPQ, and this angle here, QSP. So I can say angle SPQ is equal to angle, this is SPQ, is equal to angle QSP, and because they are the base angles of isosceles triangle. Now, in the other information, we're told that the interior angles of the triangle are in the ratio 2:3:3. So which is going to take the least and which are going to be the same? Because we are saying the base angles are equal, then this particular angle here, this will have to be the one in ratio 3 because it is the same as the one here. Okay, so if I'm to say this other one, I can call this one the one of magnitude 2, but that is a ratio. I can actually take a baseline value to say I want to call this 2x, then this one will be 3x. But look at this particular triangle. This is also supposed to be 3x, but already we have taken 26 out of that 3x. So the remainder, just this one, will have to be 3x minus 26. Okay, we just need this consistency so that we'll be able to get our answer correct and out. Okay, so if that is the case, I can say this angle SPQ, which is also QSP, is actually having 3x, and because they are base angles of isosceles triangle, isosceles triangle, just like this. Okay, now looking further in this triangle, I can identify this particular region here, this angle 26. I can see that it is also the same as this angle here. That is also going to be 26. And why am I postulating that? Is because they are angles in the same segment of a circle. You can see SR is the chord for both of them. We have S going to a point on the circumference P going to R. Then again, S going to another point on the circumference Q going to R. So these are angles in the same segment. So I can also say that angle SPR is equal to angle SQR, and the value is nothing but 26 degrees, and it's because they are angles in the same segment of a circle. So once we have this, we can look at how we can now use this information to try and solve this particular question. In the first case, we have the mandate to calculate angle PQR. Let's identify that PQR, we can see, okay, this we just got to be 26. I can say this is 26. Now from the triangle SPQ, we can see that this angle is 3x, okay. This whole here is also 3x because the two of them are base angles of this isosceles triangle we are considering. And then this is 2x. The sum of the three is going to give us 180 degrees as the sum of angles of a triangle. So I can say 3x plus, here we can see 3x minus 26 plus 26. The 26 will knock out, so it's also 3s. Okay, then plus 2x, this angle here, okay. The three of them will add up to 180 degrees because they are sum of angles of triangle. Sum of angles of a triangle is 180 degrees, and this can help us to solve for x. Plus 3x plus 3x, that is 6x plus 2x, that's 8x is 180, such that we can just find our x to be 180 over 8. Okay, that was going to be 8 in 18, that is 2, remaining 2, 8 in 20, that is also 2, remaining 4. 4 over 8 is 0.5, so x is 22.5 degrees. Then our first mandate PQR, we can see from this diagram that in the first case, angle PQR, what is going to give us? PQR, this region here, that's what we are looking for, and that is 2x plus 26. And instead of 2x, I can just say this is 2 times 22.5 plus 26. So if we want to add this, you can say 2 times 22.5 plus 26. What is that going to give us? This is going to give us 71. So this is 71 degrees. All right. Our first solution is out. In the second case, we are looking at the angle RPQ, and looking at our diagram, this is RPQ. We can see from that diagram that this is nothing but 3x minus 26. And thank goodness we have gotten our x. So this is 3 times 22.5 minus 26. So we can compute this to say, okay, let's just adjust this. So this is minus, and in the first case it is 3 and not 2. Okay, so this is 3 times 22.5 minus 26, and this is what? This is 41.5. So I have this as 41.5 degrees. And then in the third case, we are mandated to find angle PRQ, and looking at our diagram, this is PRQ, this angle here, that's what we are again asked to find, this angle here. And now there are two ways you can even go about, so even many ways, but two that I'm seeing clearly is that in the first case, you can sum the angles in this triangle PRQ to say this angle that we are looking at, if I call that y plus 26 plus 2x plus 3x minus 26, the sum of the angles in this triangle, that will be 180, and then you can get y hat since we have x already, and that will be fine. But alternatively, I can see that this angle is also the same, even though I'm calling it y, is also the same as angle PSQ. This is also the same as angle PSQ, which we have gotten to be 3x originally. And why am I saying that? Because they are angles in the same segment of the circle. You can see PQ, that is the chord. So we have PSQ as angle in one segment and PRQ as angle is in another segment. So I can say this is angles in same segment, just like we have gotten one before. Okay, and then that means that the y that I'm looking for, or angle PRQ, is just nothing but 3 times x, and that is 3 times 22.5, And if I use my calculator again, I can just say, okay, let me just remove this last set of entries. 3 times 22.5, that is going to give me 67.5. So this is 67.5 degrees. And you can see how our understanding of the circle theorems, the properties of isosceles triangle, and the sum of angles of a triangle had helped us to solve this question holistically so that our answers are done and dusted without any glitch at all. And we have the solution fine and good. All right. In this question of coordinate geometry, we are told that the coordinates of 2 points P and Q in a plane are 7,3 and 5,x respectively. So P is 7,3 and Q is 5,x, and x is given as a real number. Now, if the magnitude of the line PQ is root 29 units, we have to find the value of x, and a picture is always worth 1,000 words for me, and we have been able to locate P, which is 7,3, and you can see on the x-axis 7 between 6 and 8 is here, okay, and then on the y-axis 3 between 2 and 4 is here, so that is P. What we are asked to get inherently is the coordinate of the point Q, which is defined as 5,x. So on the x-axis is going to be 5, and that 5 is here, okay, and then we want to find the value of y. And now if you look at this critically, there's something you should get, which for me is quite interesting. Within this value, we may get two values, that this length and maybe this length, they are going to be the same, because well, this will be root 29 and this will also be root 29. That is what I'm suspecting already, but let's just find out as we solve this question together, okay? Now, by reason of our understanding of coordinate geometry, we know that the length of a side, in this case PQ, will be the square root of the difference between y raised to power 2 plus the difference in x raised to power 2. So if each of those points are taking x1 and x2, then we can have this as a particular formula. And recall, what we are given is that P is having 7,3 as its coordinates and Q is having 5,x as its coordinate. If we want to be consistent, I will take P as the first point, even though we are moving, okay, if we are moving in the positive direction, Q will be the first point. So we can say Q will be, this is x1 and this is y1. So y1 is x, x1 is 5, then P, x2 is 7, and then y2, that is 3. So if you want to use this particular formula here, you need to recollect that you have been given the magnitude of that distance to be square root of 29. So what we have is root 29 is equal to the square root of all of this. y2 minus y1. y2 minus y1 will be 3 minus x, and then we square that, okay, plus x2 minus x1 will be 7 minus 5, and then we square it. Now, look at something. Because of this, I'm having square root here, I'm having square root here. I can say, I can take off the square root, or I can say I want to square both sides of the equation, okay? And what I'm having here is as if I'm having a raised to power half, which is root a. Then if I square it, I will just have a raised to power half multiplied by 2, and these two can cut each other. So this is just a raised to power 1, and that is it. So inherently, if I'm saying I'm squaring both sides of this particular equation, that means I'm taking care of the square root in such a way that what I'm going to have is only on the left hand side, I will have 29 is equal to, on the right hand side, 3 minus x raised to power 2 will be 3 minus x multiplied by 3 minus x, okay? Then plus 7 minus 5 is 2, 2 raised to power 2, that is 4. So I just need to open up this bracket, take 29 to the other side, and solve for the value of x in this question, okay? So 3 minus x multiplied by 3 minus x is just going to be, let me just take everything to the right hand side. I'm going to have 3 times 3 is 9, 3 times minus x is minus 3x, minus x times 3 is again minus 3x, minus x times minus x is plus s squared. You need to take note of your sign, okay? Then we have plus 4. Then when 29 moves to the other side, we have minus 29 is equal to 0. So this is a quadratic already, and we can try and solve that. Let me just arrange appropriately. S squared being the first term, minus 3x will be minus 6x. Now I have 9 plus 4 minus 20. In the first case, 9 minus 29 is minus 20. Minus 20 plus 4, that will be minus 16 is equal to 0. So if we want to factorize this, we are looking at a product of terms that will be minus 16x squared, the first term and the last time. And we're looking at the sum that is going to be minus 6x. Now, normally we just look at 16 itself. We can say it is 8 times 2. Of course, we are looking at x with it. And then for the sum, let's also look at 8x and 2x. Now, looking at this, we can see that it is negative 6x that we are looking at. So, if we append minus 8x plus 2x, of course, that's going to give us minus 6x. And then, for the product, we say minus 8x times 2x. Minus 8 times 2 will be minus 16. X times x will be x squared. So, minus 8x and 2 will be very good for us to use. And that's what we are going to do now. Okay. So, we can say this is nothing but it's giving us x squared minus 8x plus 2x minus 16 is equal to 0, such that here we can say in the first two times x is common, so we have x minus 8 remaining, and the last two times 2 is common, so we have x minus 8 remaining. So this is equal to 0. Okay, and then if we look at this, we can just say x minus 8 is common to both, so we have x minus 8 into bracket x plus 2, which will be remaining after we factor out x minus 8 from them. This is equal to 0. Now, this is where it gets interesting. This is telling us that it's either x minus 8 is 0 or x plus 2 is 0. So we have x minus 8 is 0, or we have x plus 2 is 0. And that means that x is actually 8 or x is actually minus 2. Now, this is where our understanding of geometry can really come. If we go back to our diagram, you can see that I've been able to locate P, and I'm suspecting that yes, I'm going to have two answers that are going to be right in this case. Let's locate x is minus 2, but recall it is 5, x, so that x is located on the y. So minus 2, this is minus 2, minus 2, so this is where we have minus 2, and then 8, good, this is where we have our 8, and yes, this is what I was suspecting originally, that this can be the length that we have to find, or this can be the length. And you can see it's looking something like an isosceles triangle in which this side and this side, they are equal because they are actually of the same length. So the value of x that we have to find can be 8 or it can be minus 2, and we have been able to do that and find it out as required, and we are good and fine. In this question on commercial math, we are told that on Sam's first birthday celebration, his grandfather deposited an amount of $1,000 in a bank, compounded at 4% interest annually. So we need to know that here we are talking about compound interest. Okay, so we have to find how much is in the account if Sam is 4 years old. Let's list all the parameters that we are given. We need to know that we are talking about Sam's first birthday celebration. So he's not starting when he was 0 years old. And the question is asking us to find how much is in the account when he is 4 years old. So in this particular question, the time period will be 4 years old, which we are being asked, minus the period when the deposit happened, which was when he was 1 year old, and that will be 3 years. We need to get this straight and correct, otherwise our answer will be off the mark. Okay, then the principal that was deposited originally was $1,000, and then the rate, it was 4% compound interest annually. Now, for us to solve this question to find the amount when Sam is 4 years old, we can actually do it year by year, okay? But I want to use a formula in this particular case that the accrued amount is going to be the principal multiplied by 1 plus the rate raised to power the number of years, okay? And that number of years is this time that we are looking at as 3 years. So you just want to put in all the parameters there. We can say the accrued amount, which is going to be in the account, is going to be the principal, which is 1,000 multiplied by 1 plus the rate is 4%, and 4% is the same as 4 over 100, which is 0.04, and then n will be 4 minus 1, that will go to be 3 initially. So I can say this is nothing but 1,000 multiplied by 1.04, because 4 over 100 is 0.04 raised to power 3. So this is what I need to put in the calculator to solve for this question, and we'll be fine. Okay, so we have 1,000 multiplied by 1.04, okay, and that 1.04 is raised to power 3. So I can say shift square, and we can get this 1124864. So this is 1124864. Generally, finances, we only have 2 decimal places, so we can say this is approximately 1124.84. Will round down to 0 because it's not up to 5, and then we only retain 6, and this will be the answer for us. You could have taken this year after year, look at the interest for the first year, add that to the initial amount, use that as the principal for the next year, add that to the initial amount, and then you can get this final answer just as we got. But I think this is quite good and fast, and you'll find it useful also. All right. In this question on circle theorems, we are told that in the diagram A, B, C, D are points on the circle with center O here. Now, if the length of AB and BC are equal, so we have AB and BC, they are equal. That's why they even notch them. And angle ADC is 50. So ADC, this angle here, is 50 degrees. Our mandate is to find angle BAD. Okay, let's locate that. Is angle BAD. So this angle here is what we are mandated to find. So this angle here is what we are mandated to find. Okay, now looking at this particular diagram, a very crucial point that will help us is to divide this particular diagram. Since we are told that there is this length AB equal to BC, let's bring in an isosceles triangle that we can have the base of that isosceles triangle to be equal. So we can just say we want to look at a scenario in which we have from point A to point C. This is as good as it gets. Okay, and then we can see that from this particular diagram, first and foremost, we can say we want to find this angle ABC, and I can see that ABC and ADC, they are opposite angles of this cyclic quadrilateral. First, I can say angle ABC plus angle ADC, the sum is 180 degrees. Why? And why am I saying that? Is because they are sum of opposite angles of a cyclic quadrilateral. So our understanding of that will help us to solve this question. And then we have given ADC as 50. So ABC, that means that angle ABC will be nothing but 180 minus ADC, and ADC is 50. So this is 130 degrees. So we can just append it on the diagram that this is 130 degrees. Okay. Now, that being 130 degrees, I can call this angle here the base angles of the isosceles triangle. If I just call each one of them X, let me say this is this angle here, this is X, and this angle here, they will also be X. And I'm saying both of them are X because they are the base angles of isosceles triangle, meaning that I can say angle BAC is equal to angle BCA, and I'm appending them as X. And I'm saying this because they are base angles of isosceles triangle. Isosceles triangle have two of its sides equal, and then the base angles equal. All right, so that is good and fine. I think I can also look at the triangle ACD, or particularly the angle ACD, and this angle ACD will be 90 degrees. Why am I saying it's 90 degrees? Because it is the angle subtended at the circumference by the diameter AOD of the circle. So I can look at this and say angle ACD is nothing but a right angle, is 90 degrees, and I'm saying that because it is angle subtended at circumference of the circle by the diameter of the circle. So these are all geared towards my getting this particular angle BAD here. So since I have gotten that, I can now say that 130 degrees plus angle X plus angle X, this 130 plus this X plus this X, the three of them, they are the angles of the triangle ABC, and the sum of angles of a triangle is 180 degrees. So I'm postulating this because they are the sum of angles of the triangle ABC, okay, such that I will have 2x to be 180 minus 130, which is 50, and then x itself will be 50 over 2, and that will be 25 degrees. So x is 25 degrees, and that is good and fine. But I can also look at this particular region and say I can find this angle. If I call that y, okay, if I'm calling this y, I can see that from the triangle ACD, y plus 90 plus 50 is going to be 180 degrees, and because they are the sum of angles of a triangle, so I can say furthermore the angle y plus the ACD that I got as 90 degrees initially plus the 50 degrees that we are given as angle ADC plus that 50 degrees, the three of them, they add up to 180 degrees because they are the sum of angles of the triangle ACD, and with that I can find my y to be 180 minus the sum of 90 and 50, that is 140. So y is nothing but 40 degrees. And what I was originally asked to find, we are told that it is angle BAD. Now we can see from the diagram that angle BAD is the combination of x and y. Look at this. This is the interesting thing that we should be doing in our question. This angle x, okay, and then this angle y, you can see that the two of them are what constitutes angle BAD, which we are looking for. So we can easily say the angle BAD is the sum of x and y. And what is our x? We got x to be 25, so x is 25 degrees. What is our y? Y is 40 degrees. So angle BAD is nothing but 65 degrees. And with that, we've been able to solve this question, making use of the properties of triangles and the circular quadrilateral and the angle subtended at the circumference by the diameter to get the value of angle BAD as 65 degrees. So these are the kind of videos that we constantly upload on Untitled Academy so that they can help you to build your proficiency in your STEM subjects and be the best that God had created it to be. If you are yet to subscribe to the channel, it is free of charge and it's not going to cost you anything, but you will have information and access to all of our videos once we upload them. So go ahead and subscribe to the channel, click on the like button, click on the notification bell so that you will have notifications of our videos once we upload them. And until next time, God bless you.